Hi, welcome to this lesson on Euclidean geometry, ratios and proportions. Let's have a look at question 4. In the diagram below, if GHI is a kite with FG equals to 6 millimeters, GK, this length here of the diagonal, is 4 millimeters, and the ratio of GH to FI is 5/2. So this length GH here divided by this length Fi here, which is this length here, that ratio is 5/2. Okay, so we want the length of FH, which is this long diagonal here, correct to the nearest integer. So let's go ahead and put some information on this diagram based off the fact that it is a kite. Well, we know that opposite or adjacent sides are equal in length, so this is 6 millimeters. And then we also know that GH is equal to IH, however large those are. But we can actually work that out because we have this given ratio. So if I multiply both sides by Fi, right, so I get 5/2 times Fi, but Fi is 6 millimeters because it's a kite, so it's 5/2 times 6. 6 goes into 2 3 times, so that's 15 millimeters. So this length here is 15 millimeters, and this length here is 15 millimeters. And if you look, GH 15 over FI 6, 15 over 6, well, 5 goes into, 3 goes into 15 5 times, and 3 goes into 6 2 times. So you can see that that ratio is preserved. So that is the correct length. We also know that in a kite, the diagonals bisect at 90 degrees, and that this length kg is equal to this length ik because it's a kite. So this is also 4 millimeters. So we have quite a lot of information here. We have two right angle triangles, FIK and FKG, and then two other right angle triangles that are congruent, HIK and HKG. So we want the length of FH, which is that long diagonal. Okay, so how can we do that? Well, if we work out the length of FK in that right angle triangle and the length of KH in that right angle triangle, then we can just add them. So I would say in triangle FKI, we have that FK squared plus IK squared equals FI squared. That's from Pythag. All right, whenever you have right angle triangles, Pythagoras should be one of the first things that comes to your mind. So therefore, to find out that length FK squared, I'm going to say FI squared. FI is 6, okay, 6 squared, minus this length IK squared, which was 4, so squared. So that's 36 minus 16, which is 20. So therefore, FK is the square root of 20. Right, and 20 can be written as 5 times 4, so it's the square root of 5 times the square root of 4. Square root of 4 is 2 times the square root of 5, and that's in millimeters. Okay, and then in triangle IKH, so this right angle triangle here, we have that KH squared, the length we're looking for, plus IK squared, the base there, is equal to the hypotenuse IH squared. So this implies that KH squared equals IH squared, which is 15 squared, minus IK squared, which is 4 squared. So 15 squared is 225, minus 4 squared is 16. Okay, so 15 squared minus 4 squared, that gives us 209. So therefore, the length of KH, take the square root on both sides, is the square root of 209 millimeters. Okay, I'm going to leave it like that. So therefore, the length FH is equal to the length FK plus the length KH. So that's going to be 2 root 5 millimeters plus square root of 209 millimeters. So I'm going to say 2 root 5. Okay, or you could do square root of 20. It'll be the same thing. Plus the square root of 209. And that gives us 18.928, so on. So I would say this is approximately to the nearest integer, 19 millimeters. All right. So what did we use here? We used the proportionality or the ratio of these two sides of the kite. We made use properties. We made use of the properties of the kite. Okay, so the properties we made use of were that These angles bisected at 90 degrees. That gave us right angle triangles. Adjacent sides are equal in length. The shorter diagonal is cut into 2 equal pieces. Using that, we were able to form right angle triangles. We could use Pythagoras' theorem to solve for 2 lengths here. Added up together gave us the total length. All right, I'll see you in the next one.